previous section on electrochemistry, what did we do? We said we are going to find the oxidation reduction reactions, pairs, okay? We're going to stay away from the oxidation reduction agent. I'm going to get back to that. But let's just stick with oxidizing and reducing agents. Let's just stick with oxidation and reduction and understand that well, because it's not that difficult. Because if we start bringing the other into it, it starts getting confusing. So we said that we find in a reaction the reduction reaction. We write it down. In reduction, we find, then we know that above that on the table is spontaneous exo, below it on the table, not spontaneous endo. You can make it happen. You're just going to have to do different things to do so. Now, what we're saying is that here is an example. Here's a question. Okay, we're doing a few of these examples because that's what gets us into the zone and the mindset. Is this reaction, the question is this reaction spontaneous? And they've given it to us. They've said NaCl plus H2O, all right, going to equilibrium NaOH plus H2 gas plus Cl2 gas. Oh my goodness. What are we saying? We are saying that this is Na plus. We break it into ions, right? Cl minus plus, H plus, and an OH minus. Now we're saying, can we get hydrogen gas and chlorine? The key here is to say, what are we asking this to do? What are the changes? Remember, I said go back to basics. Hang on, we're saying here, we are asking H plus to change to H2 gas. We're asking Cl minus to change to Cl2 gas. This is our products. These are the reactants. See how important just that basic thing is. Because immediately it says, hang on, what have I got? I've got sodium and OH. Because what happens to these ones, guys? They stay aqueous. They will tell you that that's aqueous. Over here, this is aqueous. It's dissolved in water. Which then it means that both of those ions are spectators in this reaction. This one, the Na and the OH are spectators. They're not actually taking part. So we now say, okay, how does hydrogen become hydrogen gas? Well, this must have got one electron, then it becomes a hydrogen element. But it's a diatomic, so I must have had 2 and 2 of those, not 21. So I must have had 2. And we've seen that one before. And I just want to give you the voltage so that you can find it. That is going to be the 0 volt. This is for the time being, just so that you can locate them quickly. Then we said the Cl minus to the gas. How did this work? Well, this Cl minus, do you remember, it was ionic, high electronegativity, which means the chlorine, remember doing this? The chlorine had a high electronegativity, so it took an extra electron. The minus sign means that there's one extra electron stuck on that, isn't it? So it means that actually this sign here means an extra electron on here. So if it changes to the gas, it must lose an electron. But in order to form Cl2, there must be 2 of these and 2 electrons. Okay? So this one lost electrons. Okay? Oxidation is loss. And reduction is gain. Okay, Now they've said, is it spontaneous, right? What do we do next? We write down the reduction reaction. Let's write down the reduction reaction. Is 2H plus 2 electrons going to, in equilibrium, H2 gas. Okay, that chlorine one, just so you know, I will put in the voltage there. If you're looking for it, you will find it at Cl, where are you? Come on, chlorine. You're quite low down. Is at 1.36 volts. Okay, sorry. It's at 1.36 volts. Just stop me talking and then you can find them. Okay, I'm just going to carry on because you can press pause. Difficult for me to press pause. In fact, pointless me pressing pause because it makes no difference. Now, we say, okay, that is now our reduction. I take the oxidation reaction, I turn it round. I'm going to do that in blue. Step 1 was that one. Step 2 was turn the oxidation around. And it becomes Cl2 gas plus 2 electrons going to 2Cl minus. And then I say, okay, this is my above, which is my go spontaneous exo. The red side, okay, is going to be below. Below is no. This is endo. Okay, it's not spontaneous and whatever. And we look for where is the chlorine one. Where is this in relation to the reduction reaction? And if you look, you will see that's up there, and this one is quite low down. It's over here. Which means it's no go. It's below, it's not going to happen. That's the way we're going to deal with these. It's not spontaneous, so therefore we do that. Now, let's have a look at the displacement of the halogens. Okay, by, let's say by each other. Okay, I'll explain. All right, let's just, what I'm going to do here is we're going to bubble A, my English, bubble A halogen gas into or through a mixture containing a halide. And the difference is that is an ion. The halide is an ion. The oxide is an ion. It's a -1. So let us say we add, okay, let's first of all say, all right, we are going to put fluorine gas, okay? We're going to say number 1, we are going to bubble or add F2 gas to a solution of NaCl. So first of all, what have I got? I've got Na plus and Cl minus ions. Then I'm going to come along over here and I'm going to put my little thing in and I'm going to push F2 gas through there. What happens? Straight away, I need to know this is going to be a what kind of reaction? Displacement. Displacement means I'm looking at redox. So I first of all say, right, what have I got? On the one side, I've got F2 gas coming in, right? And what am I asking it to do? I'm asking it if it's going to form, all right, plus 2 electrons, F minus 2, 2. You will find that on the table right at the bottom at plus 2.87 volts. Right at the bottom, you'll find it there because it's the most electronegative element. So remember, I'm putting F2 into it. And what am I saying? I am then asking, will Cl minus change to Cl2 plus 2 electrons? That's what I'm asking it to do. Is that not true? This is my oxidation, isn't it? This is my reduction. And if you want to know where the oxidation Cl2 is, it is at plus 1.36 volts. Okay, it's at 1.36 volts. So that's what we're saying. That's the ion, and we're saying, will it displace it? So will that come and bubble out? And will the F2 dissolve? That's what we're saying. So what do? Step 1, as usual, boring, you know it. You write down the reduction reaction. Reduction reaction is going to be F2 plus 2 electrons, F2 gas plus 2 electrons going to equilibrium 2F minus. Okay, that is at the bottom plus 2.87. Okay, then I'm going to go back up. Okay, whoops the daisy. Sorry. I'm now going to go back up and I'm going to turn the oxidation around. The only reason we do this is just so we can see it on the table. Okay, we're not making it oxidation, oxidation, or reduction, reduction. It's just so we can see it clearly on the table. So I say it's Cl2 plus 2 electrons going to 2Cl minus. And I turn it around and I see, is it, here we go, label above, which is exo and spont. It's the go zone. Below is no. And I find that in fact my Cl2 gas plus 2 electrons is going to be 2Cl minus is above, therefore it will happen. Okay, it will happen because my turned around is above. It's in the go zone. My next one is going to be, when I take this right down, I pushed the wrong one there by mistake. Let's see, what do we ask? What did we ask? What did I ask next? Okay, okay, guess it happens. Then I said iodine. Here's another example. Iodine is bubbled through a solution of KBr. All right? Okay. Will Br2 gas be displaced? Heck, I don't know. Or liberated. There's another one. They could say liberated as well, hey? Please note. Liberated. Could also be used. Same thing. It means given off, bubbles out, gets gone. So, first of all, we are saying, what have we got? Think about the pot. In here, I've got K and I've got Br minus. And what are we putting in? This is important. We are putting in iodine, I2 gas. So what am I saying? I'm asking Br minus to change to Br2. This is a reactant, that's a product. They asked me, will it be made? So I look on my table and I find the Br one, okay, just so that I can get it, and it's going to be, let's look at it, the Br is at plus 1.07. Okay, and I write it down. And I can see the Br one, in this case I'm saying 2 Br minus plus 2 electrons, right? That's what I'm asking to happen. This must happen like that. Then at the same time, I'm saying, hang on, will iodine gas, okay, will that change into I minus? So what do I have to do? I have to have plus 2 electrons and 2 I minuses. That one, iodine, I go up and I say that's it, plus 0.54. Okay, this is my reduction one. Okay, this is my oxidation one. I turn my oxidation one around and I write it down as Br2 plus 2 electrons going to Br to 2Br minus. Then I go and I write down my reduction reaction. Here we go. I say here's my reduction. I write it down, I2 gas plus 2 electrons going to, in equilibrium, 2I minus. Okay, that's that one. Then I now say above is yes, exo, exo, and spontaneous. Right? Exo, it's above means yes. We've done this, and we say below means no. So I now find where is this located? Where is this located relative? And I go and I say, hang on, that one is actually, it's below. Okay? The Br2 is below the iodine one. So this is here. Br2 gas plus 2 electrons going to 2Bri. So the answer is no. Okay? It won't happen. Okay? It won't happen. It's not spontaneous because it's below. All right? Chlorine will displace I2 gas. Okay? Because if I take a general one, all right, if I take the general, we've got Cl2 gas plus 2 electrons. This is the reduction over there. Okay? And that goes to 2Cl minus. If you look, you will find over here that Br2 and I2 are above. Okay, so these are spontaneous and exo, and below is the F2 gas there. Okay, so chlorine, all right, will liberate those two, but it will not liberate fluorine, because fluorine in essence is our most electronegative of the lot. Okay, that's where it goes. Now, what I'm going to do is I'm going to actually cut this one short, okay, because I think the topic next deserves to be started on its own. So, unfortunately, this is a short one. Maybe you're happy about that. This is not that tough, is it, once you follow the recipe to do it? Cheers. Have a great one. Thanks for watching again. Bye.